For that ethanol that you have written H3, that is you just written short form, right? And is it a single bond is only there, right?
Oh yeah, definitely. H3H is capable of single bond. So whatever is there over here, this CH3, I've just written it as CH3. That's it. Yeah. Okay. So there are many, like, because structure is quite important in organic chemistry, there are many ways of like describing the structure itself. So we'll come to that.
Ma'am,
Yeah.
ma'am, the formula for ethanol will be C2H3OH, right?
OH किधर से आया?
Ma'am, like the H, there should be 4H, right? Written 3.
Overall formula, okay, you mean C2H4O.
Yes, ma'am.
Yeah, like if you literally count how many carbon atoms are there, how many hydrogens are there, yeah, this would be the molecular formula. But generally, that's what I was mentioning abhi, कि organic chemistry में you don't use this sort of a formula to talk about compounds. You always describe its structure. Like structure is quite important when it comes to organic compounds. Why it is important? We'll be studying isomerism in a bit once we're done with this. So it'll be quite clear, like, why is structure going to play an important role there. Okay. So you have alcohol, you have aldehyde. The next one in line is ketone. I'll just do this in the next page. So ketone, what is the defining characteristic? Like what is
ONE.
ONE. Oxygen.
Ends with ONE, that is the suffix. But how do you identify ketone?
Oxygen.
CO. Yeah, oxygen is
Yeah,
also
CO.
CO.
C double bond O, and then on both the sides there should be carbon attached there. Yeah. Or in short form, if you see, it's written, it'll be written like this: bond, CO, bond. So examples. So considering there should be carbon atoms attached on both sides, what will be the smallest ketone? So smallest ketone will have one carbon atom,
right?
Atom or three?
3.
3.
One.
It needs carbon atom on both sides, so it needs 3.
There should be one carbon atom here, one carbon. Because look at the alternative. So if I have C double bond O, or यहाँ पे instead of carbon, if I put a hydrogen here, what does
It will be aldehyde.
It become
It would be an aldehyde.
Yeah. That is why smallest ketone, because it needs carbon atom on both sides, should have minimum 3 carbon atoms. So that center may you have the double bond. Fill up the rest of the valencies. यहाँ पे एक bond है, मतलब the remaining will be hydrogen. So there's going to be CH3 over here. And one bond with carbon, so remaining 3 bonds will be with 3 hydrogens. So because this is 3 carbon atoms long, इसका नाम क्या होगा?
Propanone.
Propone.
Prop
is correct. Prop is correct.
Ketone. Propone.
Propone nahi. Again, all single bonds, so propan, on.
Ma'am, but you said hydrogen should not be there, right?
Matlab not directly attached to this carbon atom. It can be there as a filler for the valence.
Okay, the middle carbon.
Because if it is directly attached to this, it becomes an aldehyde. तभी ketone नहीं होगा. अगर center में है तभी ketone. Okay. Note this.
Ma'am, ketone is a part of carbon, ketone, right? Hydrogen is a part of ketone, right?
No, ketone is just CO, just this
No,
one.
ma'am, like in this figure, H3C, CH3 is one. You can
Oh,
add
no.
hydrogen.
This compound, because it contains this part, it is a ketone. So hydrogen और कहीं हो सकता है, but this part is the important thing that makes it a ketone. Like this CO attached on both sides with carbon. So that's what makes it a ketone. This is again like commercially important, like acetic acid. This has a common name. So this is also called acetone. So propanone is the IUPAC name, like formal name. Acetone is the common name, commercial. You guys, like a lot of you must have definitely come across acetone, used it. This is like the major component of nail polish removal. Here, acetone, propanone, like you have used a ketone. It's not like a strange chemical.
So do we say the formula as C3H6O or C2H6CO?
Neither. So if you want to describe this, you put it this way: CH3, CO, CH3, or you just say acetone. The reason for this, I'll actually we'll go through major homologous series and then I'll talk about why the structure is important. For now, note it down as it is, with the structure and all that. Don't shorten it for now. That way it will be less confusing and it's more clearer this way. So you can directly see a ketone here, C double bond over that way. Yeah. Then last one in this series, you have carboxylic acid. So carboxylic acid, what would be the naming convention that you use?
OIC acid. OIC acid.
Yeah. Oic acid. Just like how you have sulfuric acid, hydrochloric acid, these also ends with some ic acid. Okay. What would be the structure formula?
COOH.
COOH.
COS.
Yeah, this you're familiar with. Like you guys have used acetic acid in your reactions, equations, and also. So that would be. Structure, like expanded structure, if you had to describe it, this carbon has a bond, and you have double bond O and OH. Okay, simplest member of carboxylic acid. COH should be there.
COO and one more H.
H, correct. Attach this thing. So what would be the name? Iska naam?
Methanoic acid.
Methanoic acid.
Correct. You are getting the hang of this. Yes. Methanoic acid. This acid also you guys are familiar with. Iska common name?
Metal and stings formic acid.
Formic acid. Correct. That you find in Einstein's and all. So this is the common name. And methanoic acid is the IUPAC name, the form. And the next member is also something you're all familiar with. COOH and
Ethanoic acid.
ethanoic acid, yes. CH3. So CH3COOH, you're all familiar with. Common name क्या है इसका? Yeah, Dhruv. What is the common name of CH3COH? Jasmine, Mansi, you guys have sent it correct. Dhruv, what's up? You there? Ananya, that's a specific case of it. Like, okay, we'll accept it. So, vinegar is something. Dhruv has sent it on chat. That is correct. So, common name for this is acetic acid. Vinegar is a special, like it is made out of acetic acid. You take some acetic acid, it's basically a 5% solution of acetic acid. So if you take 5 ml of acetic acid and then 95 ml of water, that's what makes it vinegar. And vinegar, like it's again, it's a cooking, it's a something that you use for cooking, right? So there's a lot of modifications that may be done. Like sometimes you add some chili to it. There's something called rice wine vinegar also that has a different flavor. So when common name is asked, don't say vinegar. Iska common name is acetic acid. Okay. Okay. So these are like the different things. Like these are all your functional groups with oxygen specifically. This way you have functional groups with nitrogen, with sulfur, like a lot of different things. Okay. Another one that you guys have in your textbook are haloalkanes. Yeah. So haloalkanes, just like alkanes, just that they have an extra halogen there. That's why we call them haloalkanes. The name also follows the same format. Formula for this is you have alkyl group and X, where X can be chlorine, bromine, iodine, or even fluorine. Fluorine is also a halogen. Yeah, Veer?
Nothing.
Okay.
These halogens are the valency of 1.
Yes. Halogens, like you guys are aware of it, right? Chlorine, bromine, iodine. So valency, they all have 7 electrons. They show like the most stable one is they form single bonds to get that octet. Simplest member is again single carbon atom. Attach it to an halogen. Let's take chlorine because that's pretty common. Fill it with hydrogen. Yeah. Name also is exactly, it follows this format only. The halo part refers to kaun sa halogen use kar rahe hain. So this family of 4 elements, you call them halogens. And the alkane refers to यहाँ पे कितने कौन सा alkane use कर रहे हैं, how many carbon atoms long. So यहाँ पे halogen is chlorine and single carbon atom. So this one's name will be chloroalkane, chloromethane. Okay. So similarly, what will be the name of this compound? Who will answer? Jasmine? Puneet, see, पूरा chloro use किया ना? I didn't stop at clo. But good try. You got the logic down. Just need.
Ma'am, can you explain haloalkanes again? I'm not getting it.
Okay. Haloalkanes, simple. Halo मतलब halogen है उसमें और alkane है. Like पूरा alkane में you just take one hydrogen out and put halogen in its place. Okay. So halogen का मतलब halogens, we call this group of elements chlorine, bromine, iodine, and fluorine. So this group of elements are called halogens. Okay. So the naming convention follows exactly whatever we have written here only. Halo refers to whatever halogen is there. Like in this example, I took chlorine, right? Halogen is chlorine. Here we're just taking halo, the short form of it. So that is why we call it chloro. Then what is the hydrocarbon part of it?
One carbon, so methane.
Methane, correct. So that way. Nice. Okay. Ananya, Puneet got it now. Mansi, check. In the second example I've given, I've changed the halogen here. I took Br. So uske basis pe name also will change. Jasmine got it. Abir, you need to do a little bit of correction there, but you got the logic down. Elena, you got it correct. Nikki got it. There you go. Nice. You guys getting hang of it. What about others? Bhavika got it. Neil, Sarah, Ritvik, Tanusha, Divya, Aditya.
Ma'am, I was connecting to my headphones, so I didn't listen what you're saying to send.
Okay. From what point?
Ma'am, you what do you send in chat? I didn't listen that only.
The name of this compound यहाँ पे जो लिखा है. Tanusha got it. Neil got it. Excellent. आसान है ना अभी naming. It's very logical. Abhishek Trivedi, correct. Anirban, Ritvik, Divya. Vasudha, isn't it? So BR है मतलब Divya didn't get it. Simple, Divya. Okay, so we'll do it step by step. So कौन सा halogen है इधर in this compound, Divya? Sarah got it. Your mic is not working. Your voice is breaking. Yeah. What halogen is there? Br का मतलब क्या है? What chemical is that? You can send it on chat also, Divya. That's simpler.
Ma'am, did you receive my answer?
Bromine is correct. Who mentioned? Sarah, yeah, your answer is correct, what you sent. Mansi, yeah, I received your answer. No, I mentioned it was correct. The second time you sent it, you did it. Okay. So Divya says, okay, Br is bromine. So chlorine को हमने chloro किया. तो वैसे bromine, if we have to shorten it to halo, तो क्या बनेगा ये?
Ma'am, bromine?
नहीं, bromo, that's it. So chlorine, INE निकाल के इसको हमने O बना दिया. So that's why we get chloro. Same thing here also. Bromine, INE को निकाल के just make it O. So this becomes bromo. Then halo part we figured it out. Bromo है यहाँ पे. Alkane part, कौन सा alkane है with 2 carbon atoms? Divya? Did Divya get disconnected? Aditya, your answer is correct. I received it. Yeah. Abhi, yeah, you sent it like long time ago, no? I've already checked it. This is correct.
Ma'am, I didn't get the bromo right. I just.
Methane, नहीं, कितने carbon atoms है इधर दिव्या? You have CH2 and CH3, दो carbon atoms है ना? तो कौन सा like 2 carbon atoms, which alkane is it? Aditya Velekar got your answer. That is correct. 2 carbon atoms मतलब it's ethane है ये. So bromoethane. Yeah. So that's it. Bromoethane is the name of the compound. Yeah. Awesome. Cool. So this is how, like, this is a rough thing. Like all the examples we discussed are very simple compounds. 3 से ज़्यादा हमने नहीं गए. Like methane, ethane, ethene, prop. Just wanted to show you guys, give you guys an example of what they look like and how to figure out the names. Okay. Now, if you see, I keep writing everything as CH2, CH3, CH3, COOH. यहाँ पे भी I asked you guys to not shorten it as C3H6O, right? The reason for that is organic compounds में the structure is very, very, very important. Simple example. Suppose I okay, methane, ethane, propane, we have already discussed. I've give you guys a compound C4H10. What compound is this? Kya hai ye? Like what all can you figure out just from this compound, like from this formula?
Ma'am, it has 4 carbon atoms. It should be Bu.
Bute is yes.
And
so basically, it's a hydrocarbon, correct? As Ananya said, there are 4 carbon atoms and 10 hydrogens. So it can be bute something. Is it butane, butene, butine? Kya hoga?
it's butane.
Butane.
Butane. Okay. Abhi, from the first class, I had told you guys to treat these atoms as building blocks. I mean, they are literally building blocks of everything around us. Like the mug is made of individual atoms that make up molecules and all that. So how can you connect these 4 carbons and 10 hydrogens? So one is I can put all 4 carbons in one straight line and then fill up the rest of the valencies with hydrogen. Can I do this?
Yeah, all that
Yes,
will
ma'am.
be butane.
Yeah, this is like your butane, all single bonds, carbon, hydrogen. If you
Are
count,
we writing this?
no, like pay attention here, then I'll give you guys time to note it down. Okay, so you have 1, 2, 3, 4 carbons, then 4 plus 4, 8, 9, 10 hydrogens. So C4H10, ये बन गया. But
Can also be double bond.
double bond, check it, C4H10 होगा क्या? Let me put one double bond, 4 carbon atoms. Remaining will be filled with hydrogens. यहाँ पे 1, 2, 3 already are.
H10 नहीं होगा.
हाँ. तो कितने H आ रहे हैं?
8.
C4H8 आ रहा है ना? So this we'll not consider because it is not C4H10. If I break these carbons and build it again, I can build it again like this. I can put 3 of them and then put 1 carbon over here and fill it up with hydrogen. Tell me if you're getting C4H10 from this also or not.
Yes.
So C4H10 आ रहा है. So basically, this particular compound is also C4H10, and this particular compound is also C4H10. But can I consider both of them as the same compound? Like if I put them in a reaction, will they react? Like, will I get the same product at the end of it?
No.
Ma'am.
They both are different, right? But they have the exact same like number
Chemical property.
C4H10.
But ma'am, the structure is different.
Yeah, the arrangement of the atoms, that is, their structure is completely different. So this kind of a case where the molecular formula, like the shortened form that tells you exactly how many atoms of which are there. So this type of representation, this formula is called molecular formula. So the compounds that have same molecular formula, but different structures, so they are called isomers. So you guys, previously you learned about isotopes, isobars. You can see a pattern coming out of all of these. All of them, one thing is same, but the other thing is different. This is also exactly the same. So the same molecular formula, but different structural formula. Molecular formula matlab they have the same number of atoms that make them up, but the way they are arranged is different. So such things are called isomers. Yeah. So in this specific case, if you take C4H10, they are like C4H10 has only 2 isomers. Yeah, Divya, what's up? Yeah, you raised your hand. I'm not able to. You're muted, Divya. Can't. You need to unmute yourself.
Ma'am, ma'am, so like if the arrangement is different, then too the like common name would be same, right?
No. So I mean, because they both are completely different compounds, they'll have completely different names also. Do one thing. I'll share this thing.
But both will be butane only.
No, I'll come to the names first. So finish writing the definition here. Then I'll tell you like how do we deal with calling, like with their names part of it. Note down the definition. Then after this definition, note down the example of butane and I'll give you the names for both. Okay, so once you're done noting this down, let me know. Then I'll go forward with the rest of the thing. So when it comes to carbon compounds, you can literally treat them as like Lego blocks. You can make up any sort of a compound and it'll exist. Stability and all will differ, but it'll still be there. It's possible theoretically.
Is that example also we have to write?
Which example are you noting?
That cyclohexane and hexene.
Yeah, you can note that if you want, or you can note down the butane wala example. Both are fine. So this is another example. So hexene, again, hex matlab 6 carbon atoms, ene, there is a double bond here. This is cyclohexane. So you can see it's all single bonds, which is why it's hexane, but it is a ring structure. So that is why you add this cyclo part of it. So that's another naming convention. So whenever it's a ring structure, you add cyclo part of it. Okay. If you count, both of them are C6H12, but structures are very, very different. Can you show the butane example? Yeah, has everyone copied this? Can I change the screens?
Just a second.
So let me know when all of you are done noting this down. Then I'll switch the screen.
Ma'am,
Yeah.
I have a doubt. So if like whatever structure like for butane, you made two different structures. The other structure which was there, will it react with something or will it not react at all?
Both will react. Both are.
But it will react in different way.
Yeah, they'll react in different way. The end product will be different for both of them. So both of them are their own. You can think of them as twins. Like twins have the same genetic material, but both of them are two individual persons, right? They'll have their own life, their likes, dislikes, like goals and everything. It's like that. Like just that they have the same number of atoms, like carbon and hydrogen, even oxygen, some compounds may have, but it's end of the day, they are two completely different compounds. The only common part is that they have the same number of atoms. Okay, so I'll switch. I'll show you guys butane ka thing that we just discussed. If anyone's still noting this down, you can shout out it. Let me know. So this particular, like whenever you have a straight chain, so I'll give you guys the common name and then the IUPAC name like after this, okay? Hydrogen. Okay. So its formula is also C4H10. So this particular isomer is called N-butane. So this N represents the fact that it's a completely straight chain. Like there are no branches happening here. So that's what this N represents, normal butane. Iska naam hai, now because there is one branch with a CH3 coming from here, this is called isobutane. Yeah.
Can you repeat this one?
It's just the names. So whenever you have an isomer with a straight chain like this, all the carbons are arranged in a straight long chain, then you add this N part before its name. And whenever there is a branch with a single CH3 here, whenever you have a T-shaped kind of structure with the carbon atoms, you add this prefix of iso to it. Now, both of these are common names. Okay? They're not IUPAC names. N-butane, isobutane. This sort of a structure is called iso.
Is with IUPAC name, it will be butane only then.
For which one, Puni?
This one, butane only.
IUPAC
For
will
both
be,
of
so IUPAC name, this is going to be butane only. Iska naam ho jayega, this is 2-methyl propane. The logic behind it, like again, how, so there's some more rules for IUPAC names whenever there is branching happening here. So if there's like enough time and if you guys are curious about it, I can give you the whole list of rules, how to figure it out. But yeah, these would be the IUPAC names. Names in red are IUPAC names. The names in blue are common names. So this is like another way of finding out if they're isomers or not. Sometimes the structure can be a little confusing when it comes to really large alkanes, like with 7-8 carbon atoms and all. So in that case, if you want to figure out if two compounds are same or if they're isomers, then you figure out their IUPAC name. If they're different, then they both are different compounds. If the IUPAC name come out to be the same, then it's the same compound. Okay, so if you guys are done noting this down, there is another compound that that's become kind of relevant in the last couple of years. I want to show you guys the structure and all of that. Abhi, do you have any more question? Your hand is raised, or is that from before? Everyone's done with this? Okay, quite a few of you have mentioned. So if anyone's still noting it down, again, let me know. I'll switch back. Otherwise, we'll go forward. Have you guys heard of this compound? Somewhere, if you're watching random like fun reaction, like chemical reaction videos, or if you're reading like ingredient list or something like that, at any point, any of you are familiar with this name?
Is it using sanitizers?
Yes. If it's new for any of you, I would suggest you should be having this like at hand's reach somewhere around you. Yeah. So take a bottle of sanitizer. Any sanitizer will do, and read the ingredient list that is there. Let me see if it's here. Yeah, most of the sanitizer is going to have, especially if any of your parents are doctors or something, like if you have any of the medical solutions equipment with you, just go through the ingredients list. Should be there. So isopropyl alcohol, again, just from the name, there is a hint. You can figure out what is the structure of it. So hint one, it's an alcohol. So
OH.
OH should be there. Hint 2 propyl है, मतलब
3 carbon atom.
3 carbon there. And iso है, which means
Tree structure.
हाँ, like T shape में होना चाहिए, like middle you should have CH. So 3 carbon atoms, 3 of them are connected this way. There is a CH here, H3, and alcohol है, यहाँ पे OH होना चाहिए. So this is the structure of isopropyl alcohol, what you have in the sanitizer. Yeah. This fun fact.
Miss, why is it propyl by it?
So another thing, so whenever we we did all these functional groups, right? So one common factor is usually you end up having just CH3 or like C2H5, right? So if you take any alkane minus hydrogen, what you get is an incomplete carbon chain. So that particular group is called alkyl. Like for example, if I take CH4, subtract one hydrogen, I'm going to get CH3 and one empty bond. Like basically this is the structure. C with 3 hydrogens and the 4th valency is empty. So यहाँ पे I can put either OH or I can put Cl, I can put Br, like I can put anything else basically. So methane लेके एक हाइड्रोजन को निकाल दिया, मतलब I'll get this kind of a group. इसका नाम है मिथाइल. Similarly, if I take ethane, C2H6.
Is this involved in the structure of methyl orange?
Yes, absolutely. So methyl orange or methylene orange, it probably has like a methyl group associated with it. Why don't we just take a look? You will also be familiar with it.
But then you say you said methylene as well, so it can be 2 different things, methyl or methylene, different structures, right?
Yeah, just a moment. Methyl orange structure.
Miss, for alkyne, only from hydrogen is only taken from alkane, or can it be also from alkene and alkyne?
Only from alkane. Alkene matlab the name will be like there'll be a different modification for the name. It's not going to be simple. So alkyl is always derived from alkanes only. This is methyl orange, and considering, I think like the name comes from the fact that there are 2 methyl groups over here. So if this was not there, it would be called something different. Here. So this is another representation of it, mirror image. So you have 2 benzene structures. So this is, this is an organic compound that's a lot more complicated. So one, you have like the ring structures like benzene structures. Then heteroatoms, you have nitrogen also, and you have like sulfur ka group also. So these we have not touched, but yeah, as I told you, there's like so many different functional groups. That's why organic chemistry is like really, really large. But yeah, like the presence of the methyl groups over here, I think that's why the name came from, like it's a methyl orange. And these are the only methyl groups that are there. You can see it's not there in anywhere rest of the compound. See, organic chemistry will actually be quite fun. Like try to think of compounds from your everyday life and try to observe their structures and everything. So the more you get familiar with it, the more it opens up your mind ki acha aisa bhi ho sakta hai, waisa bhi ho sakta hai. And it becomes a lot more interesting, and once it's interesting, learning it becomes more fun and easier. So this is all about like logic. There's very less to remember compared to other parts of chemistry. And another important thing of how and why structures are important, I'll tell another thing. How many guys are fans of coffee? Puneet, Sarah, okay. How many of you actually drink coffee? What about chocolate? Chocolate, I think most of you, I've come across very few people who don't like chocolate. Like there are people, but very few. Actually, you guys have heard of Theobroma, right? What do you get in Theobroma?
Yeah, ma'am.
Deserts.
Chocolate.
Cakes and desserts.
Yeah.
You know why they call it Theobroma?
No.
So the name comes from, like, literally it has a Latin or Greek meaning saying food of the gods, but that's not the only connection. So the chemical that gives chocolate its flavor, like the reason why, like, chocolate is a flavor, right? Like lemon is a flavor, orange is a flavor. All of these are chemicals at the end of the day, like that you find in plants. So that chemical that defines, like that gives you that chocolate flavor is called theobromine. So that's kind of the connect why a dessert shop is called Theobroma. And similarly, coffee, the thing that defines coffee, like where you get that coffee cup flavor and the coffee cup kick, that is called caffeine. How many of you guys think coffee and chocolate are a good combination, that they go together? Do you think they go together, or do you think they're not good at all? Like what? Or are you guys like completely not interested in food? What happened?
Go together in what?
Generally flavors, like how should I put it? Like you eat fries with ketchup, you don't dip it in chocolate sauce, right? That way, coffee may, if you had to add, would you rather add like lemon juice in it, or would you add like chocolate sauce in it?
Chocolate.
Chocolate.
What you're saying, right?
Yeah, that's what I meant. Like those flavors go together if you had to create
Yeah,
a
they blend.
combo.
Quite right.
Yeah. So the reason why they're so connected, or why they're a combination, is are you guys able to see the structures of theobromine caffeine? Is it visible or is it too tiny?
It's visible.
It's visible.
Okay. So observe the shapes of both of these things. So you
Same
have,
structure but different.
no, it is literally the same structure. The only difference is circled here. यहाँ पे this nitrogen is connected to H, but in caffeine this nitrogen is connected to CH3. The rest of it, you see there is a double bond O, there's a double bond O. यहाँ पे there's a carbon ring, two nitrogen atoms, two nitrogen. यहाँ पे CH3, single bond O, single bond O. यहाँ पे there's a pentagon ring with two nitrogens. यहाँ पे भी pentagon with two nitrogens. There is a CH3 here, there is a CH3 here. So they are exact identical molecules except for this little detail. And that makes, like, you get two completely different substances out of it. One is coffee, like something you associate with beverages, and one is chocolate that you add in like desserts and all of that. Still, they both go together because of this similarity in their structures. So they're very closely related to each other. And both of these are organic compounds. So this is another way of representing organic compounds. You might be wondering, where are the carbon atoms, right? So the intersections that you have here, wherever there's an intersection, that would be a carbon atom. So organic compounds it is a given that, oh yeah, carbon to has to be there. That's what makes it organic. So to keep things simple, you mention the molecules if there is no carbon, like nitrogen, oxygen, all of these are there. But if there is carbon, then it's a point of intersection there. And these lines are bonds, like yahan pe sare single bonds here, but here you have a double bond between the carbons, that way. Yeah, so yeah, like even tiny differences are quite important. They're pretty significant when it comes to carbon compounds. And that is the reason structures are quite important. Like I can't just write C4H10 because I don't know which butane you're talking about if you just give me C4H10. So that is the reason why writing the structures is quite important. So this is like a completely expanded way of showing a molecule. Another easier, smaller, simpler way of representing organic molecules is condense it. So यहाँ पे एक carbon है और 3 hydrogens है. So I write CH3. Carbon is attached to 2 hydrogens. So then CH2. 2 hydrogens, so CH2, and यहाँ पे carbon with 3 hydrogens, so it's CH3. Okay. Speaking of, what is the formula for acetic acid?
CH3COOH.
CH3CO.
There is also a condensed.
What is the formula of sulfuric acid?
H2SO4.
H2SO4.
Right. Have you guys ever wondered why are we not writing this as H4C2O2? Like when we write sulfuric acid this way, so ethanoic acid ऐसे क्यों नहीं लिख सकते? Like, have you guys ever wondered why do we write it as CH3COH?
They are both different, right? OH is ion and that H is combined with.
So both these hydrogens are different, and again, because this is organic, the structure becomes quite important. So if I write H4C2O2, this can represent acid. It can also be some other compound called an ester. It can be something else also. Isomers exist, same molecular formula, different structures. So to keep things clear that, oh, acetic acid is the one we're talking about, you write it as CH3COH. Okay.
Miss Pon, you showed caffeine and theobromine right now. So what about the compounds that have a similar structure but different atoms? Do they also have a name?
No, again, they're completely different compounds. So again, different numbers, similar structures, we have already studied, right? So they will come under homologous series. So caffeine, theobromine kind of fall into the same family of compounds because the kind of functional groups they have is the same, but the number of carbon atoms, they differ in the alkyl part of it. So again, yeah, homologous series, they will they are under the same homologous series, you can say that. So all alcohols, they have the same thing. All of them have OH. Only the number of carbon atoms is different. That way. Okay. What else do we have? Isomers we discussed. Functional groups we spoke about. Then, oh yeah, saturated, unsaturated. Okay, a little bit of things about that. So let's keep all the functional group aside. So let's look at alkanes, alkenes, and alkynes. So alkanes are also called, like they fall under a group called saturated compounds. And alkenes, alkynes come under something called unsaturated compounds. Yeah. Where have you guys come across this word pehle? Saturated, unsaturated, like as what?
Solution.
Solution. So what is the meaning of saturated or unsaturated?
Saturated, like it cannot take more than unsaturated, means like if something is still left. Also like semi-solid.
Correct. So saturated matlab it is filled, it is full. Like saturated solution matlab maximum amount solute jitna bhi le sakta hai, it's taken in. So even when you say, okay, my brain is saturated with like this chemistry, like I have studied so much chemistry that my brain is full of it, I can't take anymore. Unsaturated matlab you can take some more. So the logic behind grouping alkane, alkene, alkyne is also same. The thing here is that how many more hydrogens can you add in the compound? So saturated compounds may maximum, like no more hydrogens can be added here. Unsaturated compounds may more hydrogen can be added. That's why they come under unsaturated. So what do you mean by no more hydrogen, like more hydrogen can be added? So alkanes, they are compounds containing all single bonds only. But alkenes, alkynes may you have double bonds and triple bonds. Right, okay. Let's keep it true to the valency. Okay. So the reason why I'm saying like no more hydrogens can be added here is, यहाँ पे carbon के valency is completely filled, and if I were to add extra atoms, I'll have to like break the bond and then only add. Like without breaking, it's not possible. It's completely full abhi ke liye. But with alkenes, alkynes, I can have the same number of carbon. Out of these two bonds, I can only break one of the bond and then add two more hydrogen atoms here. Similar with alkynes also, because it's a triple bond, I can break just one or two of these bonds and then add more hydrogen atoms here. Okay. So these double and triple, as Puneet saying, like he said that it can be simplified to single bonds. इसलिए more hydrogen can be added. But यहाँ पे all of them are already single bonds, तो अगर कुछ extra atoms add करना है, मतलब I need to break this, and you know, like अगर butane है, if I break it, it won't be butane anymore. So it's not like I can add more hydrogens without changing this. But in the case of alkenes and alkynes, I can do that. So that's where this difference comes from. That's why we call alkanes as saturated compounds, alkenes, alkynes as unsaturated compounds. That's where this difference comes from. ठीक है?
Okay, ma'am.
Clear?
Yes, ma'am.
Yes, ma'am.
Okay.
And which of these three has a stronger, more strength?
Strength, bond strength, double bond and triple bond are definitely stronger because, so if there's like, imagine single bond, you can cut it easily. But if you have like a thicker bond, more atoms being shared, it's going to take a lot of energy to break it apart. That's basically the reason why nitrogen is less reactive compared to oxygen and fluorine also. Like, more the number of bond between two atoms, more difficult it is to break them apart. It's simple common sense type. Like, imagine if you had a single rope versus multiple ropes, like a thicker rope with multiple strands. Which one would be easier to break? This is stronger. This is not as easy to break. But when it comes to reactivity, alkenes and alkynes are more reactive because, like, instead of breaking both the bonds, they just break this single bond, and then, in the double bond, out of two of them, they break one of them, and then they react with other things. So bond strength, at least in this context, is different from reactivity. So alkanes are less reactive. So saturated compounds are in general less reactive, more inert. Alkenes, alkynes, unsaturated, are more reactive. So the reaction sites, like why they are more reactive, is there's more number of electrons here. So that attracts the positively charged things like H plus and all of those things. Another point of difference, you can identify saturated and unsaturated by burning them. So when you burn them, they burn like very cleanly. So there's not a lot of smoke at all. All you end up getting, because there's only carbon and hydrogen, burning matlab reaction with oxygen. So you end up getting only CO2 and H2O. So they burn with a clean flame, no smoke, no soot particles. But with alkenes and alkynes, you end up getting, it's like you get soot particles there. This you can do it at your home also. You can test it out at your home with your parents' supervision. Like, don't do it when you're alone. How to test it out? So alkanes, do you know where alkanes are used? I can promise you find it in your homes every day. Do you know where would you find them? Any guesses where you find alkanes? Abir is saying oils. No. But that reminded me of an important point. Like, hang on to that. I'll talk about that also. So I'll give you a hint. The simplest alkane, CH4, which is methane, is also called
Fuel.
natural gas. Yeah, Mansi said CNG. There you go. Not just CNG, but even kitchen flame. Yeah, gas cylinder jo hai, like the gas pipes. Yeah, the gas that you cook with is predominantly it's a mixture of gases, but predominantly methane. You also have bits of butane in that, I guess, but yeah, mainly it's alkanes. So your cooking flame. So cooking that gas thing, like stove mein jo aata hai, you get it, like that consists of alkanes. Okay. One of the properties of alkanes, like if you read it, they are naturally colorless and odorless gases. But gas ka kuch to smell aata hai na. So that is added specially so that you can detect when there's a gas leak. So they add something called ethyl mercaptan to identify ki acha gas leak ho raha hai, so let's shut off that thing. But alkanes, naturally, these gases are odorless. You don't have any smell. They're just like carbon dioxide or water. You can't smell them. Okay, so you can see like gas stove pe, what does the flame look like?
Blue.
It's blue.
Some parts are yellow and some parts are blue. If it's complete combustion, then blue, sufficient.
Yeah, when it's complete combustion, when the burner is working properly, all the gas is coming out properly, it's a pure blue flame. Do you observe any smoke in the kitchen when your mom is cooking? Like bonfire जैसे smoke आता है क्या उससे?
No, ma'am. When she uses oil and something, it happens.
So that's what I meant by clean flame, like no smoke, complete, it just burns up completely without any residue or anything. Unsaturated, you have soot particles. Think of oil flame, correct? Abhi Diwali hua hai, so oil flame or ghee. If at all you put the wick in ghee, like some people do that, so that also is completely valid. Candle wax ka flame. So is that similar to your stove wala flame, or are there any like what all differences do you observe there?
Candle flame and stove flame is that there's a steady supply of gas to stove, whereas the candle can extinguish any moment.
So like diya wala flame, whenever you burn oil, ghee and all, the flame is yellow orange, and whenever like candle flame ke saath you get the best results, just put a steel spoon over the flame. So agar flame idhar hai, so just put a steel spoon at some distance over it and observe what happens. So you can catch all these soot particles that come into picture there. So the reason, as Puneet, you mentioned something, right? So alkanes ke case mein there is complete combustion. Whatever carbon, hydrogen, all of them turn into CO2 and H2O. And when it comes to alkenes, alkynes, there is incomplete combustion. That's why you have the smoke and soot particles. Yeah. And because of the double triple bond, there is a test to identify alkenes and alkynes, unsaturated compounds basically. So saturated compounds, they don't decolorize bromine water. And unsaturated compounds, they decolorize bromine water. Okay, I'll elaborate a little bit on this. What do you mean by bromine water? Have you guys heard, like bromine you've heard of, right? Do you know what color bromine occurs in?
Brown?
Yeah, correct. So bromine is a brown color liquid. Okay. And you dilute it with water because it's anyway liquid. You dilute a little bit with water. And to that, like if you add a little bit of bromine water, if you add it to an alkane, then the color remains as it is. It's still going to be brown color only. But if you add that in alkenes or alkynes, then it's going to turn colorless. Abir is asking, isn't bromine brownish red? Yeah, maroon, brown, well, like, it's that shade. I mean, it's not blue or violet or light blue. It's a dark brown color. Yeah, This is what it looks like. This is bromine. It's like a dark brownish color. The fumes are also brown, but room temperature it is liquid state. This is the liquid. And here you go. This is the test for saturation. Adds. So there's a little bit of bromine here, the bromine liquid. And test tube may there are some compounds, organic compounds presumably, considering. So you take the test tubes. So 3 test tubes here. You have an alkene in this, and then you have an alkyne in this. So are you guys able to see? Like you add 3-4 drops of bromine, like slightly yellowish this thing, and these two remain transparent.
What is the control solution?
Control solution is it's to ensure that there's nothing wrong with bromine, and like every time you do an experiment, you always have a control to test for authenticity, basically, you know, whether you're doing it correctly or not. So that solution is there to ensure that, okay, so this is bromine and this is how it usually behaves. That sort of the thing. So decolorization, like if the end of this thing, if it's transparent, it means it's unsaturated. But if it's not decolorized, like this could be like a plain water or an alkane, then it's a negative. Like there is no unsaturation there. That's the test. Yeah, I'll send this link to you guys because I know over Zoom, sometimes it comes up as a slideshow. It's not very clear. I'll send the video link on WhatsApp to you. You can see it properly. Okay. Yeah, so these are like the major differences between saturated and unsaturated. So saturated reactivity, saturated are less reactive, unsaturated are more reactive. So this ties in with your test also. So they react with the bromine, and that is the reason you have a color change. So we say it decolorizes bromine water. Color say colorless ho gaya. But saturated, because there is no reaction going on, we say they don't decolorize bromine water. Another difference you can find like physically is when you burn them, complete combustion occurs. So they burn with a clean flame. Incomplete combustion happens with unsaturated compounds. So you end up having a little bit of flame, and there's going to be soot particles that are emitted and all of that stuff. Okay. So I think this is where I'll end the session. We still have 15 minutes. So what we can do is I can go over some questions. It'll be a good revision. And next term, we'll resume. Yeah. So before we get on to it, is there anything that you guys would want to share? Anything you want to discuss about? How is it, you guys? Like, does the chapter seem easier, difficult? Like, are things making sense now? How's it going?
Questions, it will become more easy. Miss, next week we are giving full holiday, or like will there be still 2 classes?
It's going to be a full holiday next week. So we'll resume in January again.
Ma'am, it is not easy or difficult, but it is tricky. Not easy or difficult.
Accepted. Organic chemistry has that reputation. So it is very, very different from rest of chemistry, like how you've studied rest of the chapters. You have to know a lot, but application part is a lot. So if your basics like foundation is good, it'll be easy. Yeah, Aditya.
Ma'am, just wanted to know in higher grades, which has more weightage, inorganic chemistry or organic chemistry?
All of them have equal weightage. So grade 11 may you have more of physical and inorganic chemistry. Grade 12 may, like if you count by number of chapters, we have like 5-6 chapters of organic and 2 chapters of 3 C block, DF block, 4 chapters of inorganic. But those 4 chapters are like really big chapters. So if you look at the number of topics, concepts and all, they're pretty much the same. But time-wise, the time you would spend studying, practicing and all that, organic will take a lot of time, because that, I would say the way you study organic is more like physics or math, where you have to do a lot of questions to get that confidence. Inorganic is like how you do biology right now. It's a lot more studying and remembering than logic or anything else.
Okay.
Ma'am, what about physics, chem, bio? More weightage. From the 3 parts, what has the more weightage in 11th and 12th?
Oh, they're all completely different subjects.
Bio, yeah, PCM and PCB.
Yeah. Like the way you have math and science, it would be like that, right? 10th, you have math, science, social, languages, IT.
IT and languages.
11th, 12th, that gets narrower. So you'll have physics, chemistry, either math or
bio,
or both if you choose both the subjects, and then language and 5th subject. Yeah.
Ma'am.
Yeah.
Ma'am, the topics in PCM and PCB for chemistry and physics won't change, right? They would be always same.
Yeah. So whatever you studied in 9th and 10th, it's going to be stepped up a lot more. Like if this was level 3 or level 2, level 3, 11, 12 may it'll go up to like level 6, level 7. It's going to be a lot more, but these are your basics. So it's going to be built up from this on.
Okay.
Physics, though, it's a direct extension of the topics. Chemistry is a little more complicated. Whatever you studied, you won't relate directly to it, but being familiar with, these are acids, these are bases, this is how organic compounds are, the valencies, mole concept, it's going to help you a lot in 11th and 12th. It's going to make it a slightly easier. So we look at some level 1 questions. Workbook may it's all mixed up, but we'll skip the questions that we have not discussed previously. At least thoda practice ho jayega. Okay. So what are the 2 properties of carbon? So this is a direct question. Send your answers over chat. I'll ask one of you to answer. Question number 1, what are the 2 properties of carbon which lead to the huge number of carbon compounds we see around us? Neil Prajapati. Yeah. Rest of you send it on chat. Mansi got it. Elena got it. Neil Prajapati, are you there? Neil, what happened to your mic? Puneet, Rishita, yes. Take an area, send it on chat. I'll ask somebody else. Anya got it. Tanusha, can you answer this? Tanusha, yeah, you got one of them. Which is the other one?
Then is that it forms covalent bonds?
Tetravalency is what you had answered. That is correct. Covalent, matlab nitrogen, oxygen, lot of elements do form covalent, right? So what is special about carbon? I'll give you a hint. What is the property because of which you get long chains like DNA and hair and all of that?
Is it catenation?
Catenation, that is correct. Yes. So catenation and tetravalency is the reason that we see a huge number of compounds. So both have its own role to play. So catenation, that's why you get compounds with 1, 2, 3, 4, all the way up to like hundreds of carbon chain. That's what plastics are. And tetravalency ki wajah se you get compounds having single bonds, double bonds, triple bonds, with oxygen, nitrogen, so many different atoms. Okay, 4.1.3. Butanone is a 4-carbon compound with the functional group. It's an MCQ. Option A, B, C, D. Abir has already answered, that is correct. Puneet, check your answer again. We're talking about butanone. Yeah, now we got it. Elena, Aditya, Tanusha has already sent it. Neki, you give the answer this time.
Ma'am, I think it will be ketone.
Ketone is absolutely right. So the hint is in the name. ONE matlab ketone hoga. Yeah, Neil got it. Anya got it. Good. What is a homologous series? This is again definition wala question. You guys can check your notes. Scum and soap and all, we didn't do soap. Hydrogenation. These are all related to like equations. So let's not do that. 4.1.8. Oh, we haven't discussed this directly. This is a good one. Carbon exists in the atmosphere in the form of carbon monoxide only, monoxide in traces and dioxide, or carbon dioxide only, or coal. Bhavika?
Ma'am, I'm not sure about this answer.
Think about it. You can give me your logic. So atmosphere matlab around you. What form is carbon in?
Carbon dioxide is there, and
Yes.
carbon monoxide. I don't know about monoxide. I have to think about that.
So it's between 2 and 4.
Yeah.
Anybody else wants to add to it? Okay, whoever has sent the answer except for Abir, everybody else has sent the correct answer. Tanusha also has to correct herself. Who has not answered so far? Tanusha, yes, the second one you sent is right. Aditya Verlekar, what do you think?
Ma'am, it definitely exists as carbon dioxide, and
So that for
so
sure.
I think it's 3.
Okay, few of you have got confused. Option number 2 is right. So carbon monoxide does exist, and it is not a...
Oh, sorry, I read it the other way around. I read it as carbon dioxide exists in traces, and
Okay.
yeah, sorry.
Be careful. I mean, you're going to give multiple choice questions.
So, ma'am, atmosphere means what? Like coal also
No, so
is
yeah,
appropriate.
atmosphere matlab This is something that you guys came across in the lower grade, no? What is atmosphere?
Air.
Air. So air around you, coal is a definite no because coal exists in the earth. हवा में नहीं होगा वो.
But the concentration of carbon monoxide is very less.
Yeah, that's why it's in traces. Traces matlab very, very small quantity. So it's not carbon dioxide only, right? थोड़ा सा carbon monoxide भी है. बहुत थोड़ा सा. It's in traces. Very, very tiny amount. That is why this is the answer. So carbon dioxide is a lot and carbon monoxide also exists in traces. So how we get carbon monoxide is when you burn carbon, predominantly you get carbon dioxide only, but a little bit of carbon monoxide is also produced. So if you get the temperature and the pressure just right, no, or if you control the amount of carbon and the amount of oxygen, then you get carbon monoxide. So that's why it's in a very lower quantity, it's in traces. Okay. Whenever you come across this word traces, it means that tiny quantity, negligible. Yeah, Devi, what's up?
No, ma'am, for answering.
Oh, answer discuss कर लिया. Second option, monoxide in traces and carbon dioxide. This is also a good one because we didn't discuss before. Which of the following statements are correct for carbon compounds? Are they good conductors of electricity, poor conductors? They have strong forces of attraction between molecules or do not have strong forces of attraction between molecules? Option A is 1, 3, 2, 4, 1, 4 or 2, 4.
Now it will be D, 2, 4.
2, 4. Ananya, Tanusha
Yes, because they're not poor conductors.
have
and they will not have
answered
strong.
A. Okay. Ananya, why did you say option A, 1 and 3?
Ma'am, because carbon also exists in its allotropes. Like graphite is a very good conductor of electricity, and even it forms chains, and like for catenation purposes, it forms chains. So that's why I chose option.
Okay. So graphite is a very good point you brought out, but that is an exception. Like graphite is the only case. If you take coal, if you take diamond, if you take any other thing, it's not going to conduct electricity. Secondly, see, it says usually correct, like majority of the times what is correct for carbon compounds, not for pure carbon. So graphite is not something that you need to consider. Okay. If you want to conduct electricity, what do you need for that?
3 ions.
Ions.
Yes, either electrons or ions. Carbon compounds may, do you find ions, like do they have ions?
No, they're usually found in ionic compounds.
Like carbon compounds are all covalent, or covalent bond mein the electrons are like trapped between the atoms, like they can't roam around. If these electrons escape, the bond is broken. So covalent compounds are generally poor conductors of electricity. They are not good conductors. So ions या फिर free electrons होना चाहिए to be able to be a good conductor. So this is a wrong statement. This is the correct statement. The next two statements talk about strong forces of attraction between the molecules. So
Strong forces are there for ionic bonds, right?
yes.
Yes.
So it will be 1 and 4.
Yeah.
No, 2 and 4.
2 and 4.
Yeah, sorry.
Yeah. So that's absolutely right. So ionic may, because you have force between opposite charges, all of them are fixed in like a rigid structure. Like there's really strong forces of attraction between all of them. Covalent bonds may, if this is one molecule, that's it. Now, these two atoms don't care about any other molecules surrounding it. So they don't have strong forces of attraction between their molecules. So this is wrong and this is correct. Yeah. So that is the reason carbon compounds have really low boiling point and melting point. That's why a lot of your methane, ethane, butane, all of these are gases. And if you take something with a high molecular mass, it ends up, like if you take oil that's still liquid at room temperature, ghee, like if it goes below 20 degrees, it freezes up winter, like it becomes solid. So you can see they all have low melting and boiling points. Yeah. Any doubts, any questions for this particular question? Or yes, no? Anybody else think it should be the other way around or something? Quite a few of you have answered B. That's why I'm asking. Like, do you guys get the logic of this? Puneet, Anirban, Anusha, yes?
Miss,
Yeah, I got it.
generally, we have to
Hmm?
His answer is
Answer is 2 and 4. So option D.
Miss, just one doubt. Miss, they are told usually, right?
Usually,
And then carbon compounds, only one, that is graphite.
graphite is a good conductor. Carbon, no, that is pure carbon ke case mein. Carbon compounds, anything that forms an ion will be a good conductor. So a little bit like acetic acid will conduct to some extent, not as good as sulfuric acid and all, but any acid. That's the reason you add some lemon juice, like fruit juices can conduct because they are acids. They have that, like they can ionize into H plus and the anion. That also like very specific cases when the atoms are small. For larger molecules, again, that's going to be like fatty acids and all are not good conductors. It's going to be difficult. So there are few exceptions to it, but generally they are poor conductors. Like 90% of the cases, they're poor conductors.
Okay.
Okay. Next, Buckminster fullerene is an allotropic form of this. Everybody should be able to answer. It's a direct one. Yeah, absolutely. Whoever has sent answered, absolutely right. Huh. Anirban, what happened? Buckminster fullerene kiska allotrope hai? Check your notes, flip the pages.
My mistake. My mistake.
Okay, this is connected to reaction.
This addition reaction is same as reduction only.
Not necessarily. I mean, more or less because you're adding hydrogen to it. Yeah. Sometimes you end up adding a H and OH also. In that case, it's not exactly redox. So reactions, organic reactions they have completely different categories from your other combination decomposition and all, because the mechanism they follow is also very, very different. It's very dependent on the catalyst and the reagent present. So the reactions part of it will go in detail in grade 11, because that's where the real trouble begins. 12. In which of these compounds OH is the functional group? Puneet has already sent the answer. Nice. That was fast.
We don't have soaps and detergents. Na?
I don't think, doesn't look like it. None of your schools have taken it up. कौन है ये? Tanusha, check the table that we did earlier today. अगर OH alone is there, you don't have COH. So क्या होगा? Mansi, Sara, yeah, Tanusha corrected it. Aditya is correct. Elena, yes. Anirban, check again, check the table. COOH nahi hai, it's just OH. Neil is correct.
Ma'am, you're talking about 4.1.12, right?
Yeah. Bhavika, yes. Nikki got it. Another hint, whoever has not answered yet, OH is alcohol. So alcohol matlab, what should be the name? Ananya, yes. Anirban, have you corrected your answer?
No.
Not yet, okay. This is a direct question. Like we have made notes about this. We revised it today also. Check and answer.
Ma'am, after you have written alcohol, it is pretty direct.
Yeah. So answer to this would be butanol. Okay. Revise that table, keep studying it, keep referring to it. Next, dot structure of nitrogen. Okay. There is a typo here. None of these are correct. Let's skip.
Ma'am, none of them are correct.
Yeah.
They are all wrong.
There should be a triple bond.
I think the C1 they're missing a triple bond.
2 and 4 are like exact same option. So one of them should be a triple bond. Seems like this is copy pasted. Yeah. Look at 15. यहाँ पे भी typing has. So this is a double bond. यहाँ पे single bond है. So यहाँ पे there should be a triple bond. यहाँ पे there should be, let's put a double bond. So यहाँ पे which is the correct option? So I will say. Yeah, Ananya, Mansi, Tanusha, Elena have answered. Well done, girls. Bhavika has also answered. Rishita, Aditya Velekar, Ame, I've not gotten answers from you guys for a while. Neil, correct. Puneet, Neki, Divya, Anirban, come on, guys. No, you can do it. Aditya Mundra, yes, correct. Puneet, correct. Divya, correct. Aditya, the question is asking for ethyne. So अगर Y नहीं है, तो check the table. क्या होना चाहिए structure में? Anirban, yes. Rishita, yes. Neki, yes. Sarah, yes. Yeah, Aditya, you got it now. So YNE matlab it's an alkyne. So triple bond should be there. This is the correct option. Okay. This is reaction soap, benzene. You just want to answer 18? Structure of benzene.
Ma'am, can you repeat what is benzene?
Benzene is C6H6. Okay, so that's like a direct thing. The structure is third option. Looks like this. So benzene, it's a ring structure, has alternating single and double bond. If this is not clear, I'll just draw it over here. So we have a hexagonal structure. We have alternating single and double bonds. And remaining valency is fulfilled by hydrogen. So its molecular formula is C6H6, the simplest aromatic compound. This is benzene. Vinegar is a solution of, you guys want to take a guess? Like we discussed it before, I'll give you the answer, but if you want to take a guess. Yeah, whoever has answered, Abhimansi, Alina, Aditya. Acha, Mansi, that you sent for the previous thing. The last answer you sent is wrong. Tanusha got it. Neki, no. Puneet got it. Neil got it. Aditya got it. Sarah got it. Yes.
Ma'am, which Aditya?
Whoever, both of you answered correctly.
Ma'am, are they saying 50% acetic acid, 60% water like that, or both are for the acetic acid part only?
Acetic acid part only. So, like,
okay,
either it's somewhere between 50 to 60%. This says it's somewhere between 5 to 8%. So that's what these percentages mean. Ananya, Bhavika, Anirban, Mansi, Neki, yes, all of you guys. No, Neki, that is not correct.
Ma'am, 3 by mistake. The type.
3 is correct. So vinegar is a solution of acetic acid in water, and it's just 5 to 8%. It's not 50, 60% of this thing. Okay. If it was 50, 60%, it would be really difficult to cook with it. You'll have to add like 2 drops of it. Dot structure of water. Yeah, Puneet got it, Mansi got it, Bhavika got it, Neki got it. Tanusha, yes. Anirban, no. Elena, yes. Technically, Anirban, yeah, but like if you look at the options, they've specified the lone pairs on oxygen also, right? So take that also into account, see which one would be correct. Divya correct, Neil correct. Yeah, Anirban, now you got it right. Yeah. Rishita, Aditya, Verlikar, Amay, you guys answering? Sarah, correct. Ananya, no. Always remember, wherever you find electrons, no, they're always in pairs. Whether they're lone pairs or whether they are in a bond, there should always be, electrons are always present in pairs. So that way also you can like eliminate some of the options and you can figure out. So the correct answer for this would be option 3. Rishita, what happened? So 6 electrons from oxygen and 1 each from hydrogen. So these two are shared pair of electrons, right? Both of these. So in this, 1 is coming from hydrogen, 1 is coming from oxygen. Same thing here also. So oxygen has 1, 2, 3, 4, and 1 each it's sharing, 5, 6 it's sharing with this, which that's not clearly shown. So another way you can figure is, yahan pe there's only 1 electron, right? Electrons are always shared in pairs. So oxygen ke 6 electrons hai, but hydrogen ke kidhar hai? There should be another one here which is missing. So if you look at question 3, it's there. So this, I can see how this can get confusing, but if you look, like if you compare it with the other options, oxygen ke 8 electrons, all of them are there, which is not over here. So this would be more accurate. Always show the lone pair electrons also when you're drawing dot structures. Okay. I'll check the questions and I'll tell you guys which questions to do. So we will close out for this particular term. It's already 5:15 and missed out on the time.